All right, so the property that we're going to start talking about right away is electric charge. And so the first question, of course, is what is charge? Well, charge is a property of matter in the same way that mass is. So when we talk about matter having some mass, matter also has some charge. So you might talk about it in the terms of particular particles, right? The proton has some mass and it has some charge. So what does this mean? Well, what do we know about mass? And one of the things we know about mass is that mass has a gravitational property. So there's the gravitational property of mass. And in a way that we may not have been quite as explicit about this last semester, but in a way that's sort of going to tailor in well with the way that we'll talk about charge this semester, mass creates a gravitational field. If you've got empty space and you bring mass and put it in the middle of that empty space, that mass is going to create a gravitational field. If you then bring a second mass into that space, it's going to interact with the gravitational field of the first mass through the gravitational force. So this is why when we calculated Newton's universal law of gravitation, we said, oh, it's going to be some gravitational constant, big G, times m1 times m2. So one of those masses was causing the gravitational field. The other one was feeling the gravitational field. And then the gravitational force is always attractive. So to explain a force that's always attractive, we only needed one kind of mass, which is why we said that mass is always positive. And so we'll come back to this idea in a minute. All right? So in terms of thinking about the properties of electric charge, so what do we know about electric charge? Well, you guys have known for a long time that unlike charges attract one another and like charges repel one another. So what this means is that if I've got a set of charges, if I've got two that are different, they're going to attract each other. If I've got two that are the same, it doesn't matter which one they are, as long as they're the same, they're going to repel. So red ones repel, blue ones repel. So we've simply assigned them labels, and this is sort of thanks Ben Franklin, right? He's the one who came up with the idea for calling them positive charge and negative charge. And so those are the labels that we've assigned to the two different types of mass. We have a positive charge, or the two different types of charge. We have a positive charge and we have a negative charge. Okay, so unlike charges attract, so if you have a positive and a negative, they're going to attract. Like charges, whether they're both positive or both negative, are going to repel. What's the next thing we know? Well, electric charge is always conserved. So you can't get rid of charge. Right? You can rearrange it, you can change it, but you can't destroy it. Right? And then the other thing that's important is we know that charge comes in discrete packets that are multiples of the basic electric charge, E. So our little sort of subscript E, or our cursive E here, sort of math type E, I guess, is equal to 1.602 times 10 to the minus 19 coulombs. So the unit of charge is coulombs. That's going to be big C. That's our SI unit for charge. So if you think about neutral hydrogen, so neutral hydrogen has one proton. Proton has a charge of positive E. It has one electron. The electron has a charge of negative E. And since you've got both positive E and negative E, the atom itself, plus E, plus minus E, that's another way of saying zero, so you've got neutral hydrogen. You've got a neutral atom. Neutral material is another way of saying, as a general rule, it doesn't mean no charge. As a general rule, what it means is same number of positive and negative charges. So just like in our neutral atom here. If I add an additional electron, so what this means is now I've got a negatively charged atom because it's one proton, positive E, two electrons, so minus 2E, so I've got a net charge of minus E. I've got a negatively charged atom. And so negatively charged is a way of saying I've got an excess number of electrons, an excess number of negative charges. Positively charged, well, the easiest way to make an atom, a hydrogen atom positively charged is just take away the electron. And so a positively charged atom is one where basically I've just ripped the electron away and all I'm left with is a proton. So positive charge, as a general rule, is due to the removal of negative charges. So what we'll talk about is the fact that the negative charges are the ones that usually are the ones that are moving around. The electrons move, so we get positively charged things by taking electrons away, negatively charged things by adding electrons to them. So let's come back to sort of the way that we set up mass on our very first slide. So we say if charge is a property of matter like mass, then how does charge act like mass? And again, this is sort of previewing what we're going to spend the next several weeks talking about. But the big idea here is charge creates an electric field. So again, if I have empty space, there's nothing out there, and I bring some charge into that space, it's going to generate an electric field. If I then bring a second charge into that electric field, so the second charge is going to interact with the electric field of the first charge, that should be charge, through the electric force. The electric force can be either attractive or repulsive, which is why we actually need two kinds of charge. So I just need one kind of mass because I only have to explain one behavior with the gravitational force. I need two kinds of charge, positive and negative is what we've chosen to call them, because I have to explain two kinds of behavior. So this is really we're sort of going to start by thinking about the forces, and then we'll work up to the electric field. But fundamentally, charges generate electric fields. And then when you put another charge into that electric field, it's going to feel an electric force that causes it to move the way that we think of forces pushing or pulling things around. So this is we talked about these field concepts as being our non-contact forces. And so the reason that the electric force is a non-contact force is because the electric field goes out in space, and so it doesn't need the other charge to touch it. The other charge perceives the field through the electric force. So that's why they don't have to be in contact to push or pull on each other. And this is why the field idea is fundamentally important to what goes on with non-contact forces. And all this is sort of what we'll spend the next several weeks talking about: electric forces and electric fields.